Hello everyone. I'm sorry if you didn't get to see my workshop today. I just wanted to quickly show you how to do derivation trees for Comp 105 in LaTeX. We're going to start with an empty document here as part of the template provided. To get to the template, please go to sites.tufts.edu/cslol. And in this post I made, resources for this week's LaTeX workshop, go to the LaTeX Workshop 2006 file, and then you can open it as a template. This template will include Comp 105 example, which I'll be working on here. We're going to start with our basic document class article, and we're going to import the two packages, bus proofs, which you've seen in class, and I'm going to explain a way of thinking about, and math part here, which I like better, but you need to be a little more verbose. So let's start with bus proofs. So to make a proof tree, we enter into an environment proof tree, and we end our environment proof tree, and then we put whatever we want in here. So we get three commands. I'm going to comment them out. We get axiom C, which takes an argument. We get Unary inference C, which takes an argument. We get binary inf C, which takes an argument, and then we get trinary inf C, which takes an argument. I like to think of these as pushes and pops. So axiom C, which we can see right now, and we're going to just give it an A, will push an A onto our stack. I like to think of bus proofs as a stack machine. I'm going to set this example as main so we can see it in action. And we should just see an A floating by itself over here. Axiom C will push an A onto the stack of our proof, and then proof tree will take whatever's on our stack and print it when we hit to the end. So imagine this. Our stack at this point looks like this, the stack containing A. Now let's say we want to put that A over something. Well, if we want to have something that looks like A over B, we need to pop that A off, put it over B, and then put that new A over B onto the stack. So we can use the unary inf, which is like a pop one and push, to pop the A off the stack, push it over whatever we put in its argument, B, and then push that nonsense back on the stack. So what that will give us now is our A over B on the stack, and it'll print that. Now, what if we wanted A and Z over B? Well, then we'd need to push Z, A and Z onto the stack, so it makes our stack look like whichever order you like. It pushes an A onto the stack and then a Z onto the stack. But our unary inference still is wrong. It's the wrong thing to use, because now here we take, what this would do is it would take the Z off the stack, put it over the B, but we still have that A, and that's two things on our stack, so the proof tree does not know what to show. So if we want to pop both those off the stack and then put them over the B, we need to do a pop to and push, which is what we can do with the binary inf C. So binary inf C will pop the Z and the A off the stack and put it over the B and put that mess onto the stack. So now we have a Z and an A over a B. So we only have one thing on our stack, so proof tree knows what to show. Let's say we want to put this whole thing over a D. So this is what's on our stack. So now we can take this whole thing and we can put it over a D. So this unary takes whatever's on the stack, which is this whole thing, and put it over a D. And if you saw our D was a little bigger, so I'm going to add a couple D's so that it'll extend the line out appropriately. It'll format it to whatever's underneath. Note though, so now let's say I wanted to take three things. So I want to take this whole thing and two other things, let's say an E and an F, and put them over a G. So if I'm going to put three things over a G, I need to trinary inf C and put it over a G, but I only have one thing on the stack. So I need to put two more things on the stack, so I'm going to push with axiom an E. So now I have my ZA over B and an E on the stack. I'll put it on the correct side. And now I want to push an, and that's still not enough though. I only have 2 things on the stack. So I'm going to push an F. I want an F, an E, and a ZA over B. So I'm going to use axiom C to push an E on the stack. So I'm pushing F on the stack. So now I have my garbage from before over here on the stack. I pushed an E, I pushed an F, and I need to spell correctly. Trinary, inf C. And now you see I have 3 things on the stack, and I put them over the G, and then I put that whole mess on the stack. So now I have F, E, ZA over B over G. And that's 1 thing on the stack, and so my proof tree knows how to show that. And you can see that over here. If you find this to be limiting, it's because you can only put 3 things over something else using the trinary. So what if you want 4 things? So you can't use proof tree for that. So instead we will use math partir. Please enter a math environment. You can do begin math. I like begin equation because it puts its center on its own line and doesn't have the formatting issues that the double dollar sign has. I'm then going to use the command infrarule star, which takes 2 arguments, what goes above the line and what goes below. So similar to before, I can have an A and a B. And you'll see over here I should get an A over B. In order to use infrarule, you also need to include the math library packages, which you can see in my math. To use equation star, you have to get the math library packages. So please go to my math.tech in the same project and grab those 2. So now we have A over B. If you would like to label this, you can add a label with either the left or right operative, equal sign, and then the label name. What if you want now to do 4 things above the line? Well, you can just put 4 things in here. I'm going to put a C over D with an infrarule star. I'm going to put an E over F with an infrarule star. I'm going to put a G over H with an infrarule star. And I'm going to put an I over J with an infrarule star inside the first argument to the top infrarule. I didn't do my nesting right. Begin equation, infrarule CD, infrarule EF, integral GH, integral IJ, and then that should close that, and then that should be fine. I guess it was just the spacing. And you see I get 4 things above it. If these things are too close together, we can use a new line to space them out. As you can see here. And you can use, and so like let's say I wanted to label this I over J, I could label it with right equals label. And you can see it'll put a label next to just that guy. But then on the top level, I could do left equals outer label, and it'll put the label next to the bar of the one it belongs to as an optional parameter. So I hope this was helpful. I hope this helps you do your derivation trees. You can keep nesting these. I like to kind of start with alphabet letters and then replace the alphabet letters with the part of my derivation. So I get the form first with infrarule and then replace them with the parts of my actual proof. I hope you have luck. Thank you.